Customer Segmentation Case Study. In this lesson, we solve a real-world customer segmentation problem for market research. Segmenting customers allows businesses to tailor marketing and services to different customer groups. You will learn to load, explore, segment, and analyze customer data to uncover actionable insights. By the end, you will be able to perform demographic segmentation and find key customer groups. Running the cell now. We import warnings so we can ignore non-critical warnings during analysis. We disable Python warnings for cleaner output. We import pandas for data manipulation, which is essential for customer data analysis. We import NumPy for numerical calculations required for segmentation techniques. We import OpenML so we can fetch real-world marketing datasets. We import standard scalar to normalize numeric features before clustering. We import k-means, a popular segmentation algorithm, from scikit-learn. We import matplotlib and Seaborn to create insightful business visualizations. Running the cell now. Conceptual background for market research data. Market research data includes survey responses, customer demographics, purchase records, and transactional data. Each row typically represents a customer, with columns for attributes like age, region, behavior, and satisfaction. Beginners often mistake categorical values for numeric, overlook missing values, or aggregate data incorrectly. Interpreting scales, like Likert or NPS, incorrectly can result in misleading insights. Running the cell now. Beginner example, loading a real customer survey dataset. We will use OpenML's customer satisfaction dataset to practice segmentation. Columns include customer demographics, services used, and churn status. Running the cell now. We load the customer satisfaction dataset from OpenML, ensuring we have real-world survey data. We extract the data in Pandas data frame format for easy analysis. We print the dataset's dimensions to quickly check record and column counts. We preview 3 customer records to check the data's structure and content. Running the cell now. This output shows the dataset loaded from OpenML, confirming it contains 7,043 rows and 20 columns, which capture customer demographics, service usage, and churn status. The first 3 rows illustrate key columns like gender, tenure, payment method, and churn, helping us understand the data structure before we begin segmentation. This step ensures we know what features are available to analyze customer satisfaction and predict churn. Beginner example, summarizing customer demographics. Understanding the distribution of customer demographics is the first step in segmentation. Let us view gender and age-related columns. Running the cell now. First, we count how many customers are male or female to see which group dominates. We also check how many customers are senior citizens, as age is a vital segmentation factor. Running the cell now. Here we see the distribution of customers by gender and senior citizen status. The counts show a fairly balanced gender split, with slightly more males than females, while most customers are not senior citizens. This helps us understand key demographic segments before diving deeper into customer behavior. Here we describe key demographic variables with basic statistics, helping us understand our customers before segmenting. Running the cell now. This summary shows that the dataset has 7,043 customers, with a roughly even split between 2 genders, where male is slightly more common. The binary columns senior citizen, partner, and dependents highlight key counts and proportions, such as about 16% being senior citizens and most customers not having partners or dependents. This helps us quickly understand customer demographics before moving on to segmentation. Beginner example, checking for missing data. Missing values are common in surveys and must be handled to avoid bias segments. We will check if there are any missing responses in the dataset. Running the cell now. We count missing values in each column to ensure our analysis is accurate and does not miss important information. Running the cell now. The output shows that none of the columns in our dataset contain missing values, as indicated by the 0 counts for each feature. This confirms that all responses are complete, allowing us to proceed with analysis without needing to handle missing data. This step is crucial to ensure our segmentation or modeling is based on clean, reliable information. How would you handle missing demographic data in segmenting customers? Intermediate example: exploring service usage patterns. Segmentation can be based on the services customers use. Let us compare use of internet and phone services. Running the cell now. We analyze how many customers use different internet and phone service combinations, which helps define meaningful segments. Running the cell now. This table shows how many customers use combinations of internet and phone services, segmented by internet type. Notice that all fiber optic and no internet customers have phone service, while DSL customers are split between having phone service or not. This highlights usage patterns that can guide targeted service strategies. We visualize the customer count by internet and phone service using a bar chart. This helps stakeholders quickly identify customer segments for targeting and upselling. Running the cell now. This stacked bar chart shows how customers are segmented based on their use of internet and phone services, highlighting the count of customers in each segment. Notice the differences in segment sizes, which helps us understand patterns like whether more customers use both services or prefer just one. This visualization connects to our goal of comparing service usage to identify distinct customer groups. Intermediate example: segmenting by monthly charges. Customers can be grouped into segments based on spending. Let us create spending groups using monthly charges. Running the cell now. We create segments based on how much customers pay monthly, labeling them low, medium, or high spenders. This is a common way for marketers to prioritize customers for promotions. Running the cell now. This output shows the distribution of customers across 3 spending segments: low, medium, and high are based on their monthly charges. Notice that the segments have fairly balanced counts, with the high spenders being the largest group. This confirms our code effectively categorizes customers into meaningful spending tiers for targeted analysis. We plot the distribution of spending segments, providing a visual summary for decision makers. Running the cell now. The count plot displays the number of customers in each spending segment based on their monthly charges, allowing us to see how many fall into low, medium, or high spenders. Notice the relative size of each segment's bar, which directly reflects customer distribution and helps us understand the composition of our customer base. This visual confirms our segmentation logic and sets the stage for analyzing behavior or targeting strategies by spending group. Intermediate example: relationship between contract type and churn. Business insight: churn can be higher for certain contract types. Let us analyze churn rate across contract segments. Running the cell now. We compute the percentage of customers who churned, grouped by the type of contract. This reveals which contract types may need attention in retention strategies. Running the cell now. This output shows the proportion of customers who churned yes versus those who did not no across different contract types. Notice that month-to-month contracts have the highest churn rate at about 43%, while longer contracts like 1 year and 2 years show much lower churn rates, around 11% and 3% respectively. This highlights the key business insight that customers with shorter contract commitments tend to leave more frequently. We create a stacked bar plot to easily compare churn rates across contract types for stakeholders. Running the cell now. This stacked bar chart visualizes the proportion of customers who churned versus those who stayed, segmented by contract type. Notice how the orange section, churned customers, varies in size across contract types, highlighting which contracts have higher churn rates. This visualization directly supports our goal of identifying contract types at greater risk of losing customers. Advanced example, standardizing data for clustering. K-means segmentation requires standardized data for reliable results. We will select numeric columns and standardize them. Running the cell now. We select features relevant for segmentation, such as monthly charges, total charges, and tenure. We handle blank spaces and missing values by replacing them and ensuring the data is numeric. We create a standard scaler to normalize the features. We scale the data, putting all variables on an equal footing before clustering. Running the cell now. Why is it important to standardize variables when using k-means clustering? Advanced example, finding optimal number of customer segments. K-means requires us to pick the right number of segments, k. We use the elbow method to visually determine the optimal k. Running the cell now. We try different cluster counts and compute inertia to find the best segmentation resolution. The bend, or elbow, in the resulting plot suggests where adding more clusters yields diminishing returns. Running the cell now. This elbow plot shows how inertia, or within-cluster variance, decreases as the number of clusters increases. Notice the sharp bend, or elbow, around 3 clusters, indicating that adding more segments beyond this point yields diminishing returns. This visualization helps us select the optimal K by balancing model complexity and fit quality in customer segmentation. We fit a 3-segment K-means model to the standardized customer data. We assign each customer to a segment and count how many belong to each, giving us actionable groups. Running the cell now. Here, the code assigns each customer to one of 3 clusters using K-means with K equals 3, then counts how many customers fall into each segment. Notice that the cluster sizes are fairly balanced, which suggests K equals 3 might be a reasonable choice for segmentation. This step helps us evaluate the distribution of customers across clusters after picking K in the elbow method. Advanced example, profiling customer clusters. Segment profiles tell us how clusters differ in business variables. Let us summarize average values of each segment. Running the cell now. Before profiling clusters, we ensure that all selected features are numeric. We convert the feature columns to numeric and coerce invalid values into missing values. Next, we drop any rows where the cluster label is missing. Now we begin building the cluster profile summary. We reference the data frame. We group the data by the cluster column and select the feature columns. We calculate the mean of each feature within each cluster. We close the Group B aggregation block. Finally, we print the cluster profile to interpret segment characteristics. Running the cell now. This output shows the average values of key business metrics for each customer cluster, helping us understand their distinct profiles. Notice how Cluster 1 has notably higher monthly charges, total charges, and tenure, indicating longer-term, higher-value customers, while Cluster 2 has the lowest charges. This summary validates our segment differences and supports targeted strategies for each group. Cluster profiling helps us understand the average behavior of each segment. In advanced analysis, we may visualize this profile using heat maps for clearer interpretation. We visualize monthly charges per cluster to help business teams quickly spot high and low spender segments. Running the cell now. This box plot visualizes the distribution of monthly charges across different customer segments, highlighting differences in their spending patterns. Notice variations in medians and spread between clusters, which helps us understand how each segment differs in terms of monthly billing. This visualization supports the profiling goal by revealing key financial characteristics of each cluster. Error handling, dealing with missing survey responses. Missing values can break segmentation algorithms if not addressed. Let us simulate missing data in monthly charges and see the effect. Running the cell now. We create a copy of our data and introduce 5% missing values to monthly charges. This allows us to practice handling missing survey data before analysis. Running the cell now. The output shows that 352 values in this monthly charges column are now missing, representing 5% of the data as intended by the code. This highlights how even a small fraction of missing entries can be introduced and needs to be managed carefully, since these NANs could disrupt segmentation algorithms if left unhandled. We attempt to compute the mean with missing values and catch errors. Handling missing data is required for reliable customer segmentation. Running the cell now. For practice, try filling missing values with the median monthly charges. Error handling, grouping by the wrong variable. Grouping by the wrong fields causes misleading business insights. Let us see what happens if you aggregate by a non-segmentation variable. Running the cell now. We group data by payment method instead of a true segmentation variable and compute mean monthly charges. This often leads to insights that are not actionable for marketing segmentation. Running the cell now. Here, we calculated the average monthly charges grouped by payment method instead of a meaningful segmentation variable, which causes misleading insights. Notice the wide range in values, especially the high average for electronic check and low for mail check, which may not reflect actual customer segments. This highlights why grouping by the wrong field can distort business conclusions and lead to incorrect decisions. Error handling, misinterpreting Likert or NPS survey scores. Scores like 0 to 10 NPS measure satisfaction but should not be averaged blindly. Let us see an appropriate and inappropriate way to analyze NPS-like data. Running the cell now. We create a small NPS-like score set. Computing the mean score is not the right NPS analysis. We count how many customers are promoters and detractors. We correctly calculate the NPS score for actionable business insight. Running the cell now. Here, the output shows two different ways of summarizing NPS-like scores, a simple average of 6.17, which can be misleading for satisfaction data, and the correct NPS calculation of -16.67%, reflecting the balance between promoters and detractors. Notice how the average ignores the distribution and impact of high versus low scores, whereas the NPS score captures customer sentiment more meaningfully, reinforcing why averaging such data is inappropriate. Best practices: segmentation, cross-tabulation, and trend analysis. Use segmentation to define actionable customer groups. Employ crosstabs for comparing segment behaviors. Use trend analysis over time for strategic decisions. Always check for missing data and standardize features for clustering. Running the cell now. We use crosstab to summarize churn by spending segment, helping marketing teams identify high-risk, high-value customers. Running the cell now. This cross-tabulation compares customer churn rates across spending segments, revealing that higher spending groups have proportionally more churned customers. Notice how the counts in the yes churn column increase with the spending segment, highlighting a key pattern for targeted retention strategies. This output exemplifies how segmentation combined with crosstabs helps identify actionable groups and behaviors for focused interventions. We visualize how contract type varies within each spending segment to support retention analysis. Running the cell now. This stacked bar chart shows the distribution of contract types within each spending segment, highlighting how customer behavior varies across segments. Notice the differences in contract counts, which help identify which contracts are prevalent in low, medium, or high spenders, guiding targeted marketing strategies. This cross-tabulation visualizes segment-specific patterns crucial for actionable insights in segmentation analysis. End-to-end market research problem: segmenting and targeting customers. Let us walk through the process from data to actionable insight. We will identify key segments and recommend a strategy. Running the cell now. We create a segment matrix showing how cluster, algorithmic segment, and spending, business segment, overlap. This enables precise targeting for cross-selling or retention campaigns. Running the cell now. This table shows the number of customers in each spending segment across the 3 clusters identified. Notice how cluster 0 and 1 primarily contain medium and high spenders, while cluster 2 is dominated by low spenders. This highlights meaningful differences in customer behavior, guiding us toward tailored marketing strategies for each segment. We identify customers who are high spenders and have not churned. These are ideal for loyalty programs or exclusive offers. Running the cell now. This output shows that there are 1,760 customers who are both high spenders and have not churned, highlighting a valuable, loyal segment. Noticing this count helps us understand the size of our best customers, which is essential for targeting retention strategies. This step connects to the lesson's goal of identifying key customer segments for focused marketing efforts. Try running similar queries for other segments and compare insights. Watch our YouTube channel for more end-to-end market research tutorials.